everyone. Today we're going to be learning about arc length and sector area. I'm going to present my screen, but we are going to be on page 6 and 7 of your packets. Right, so if you'll open up your packet to page 6, we're going to start with arc length. And I want to talk to you a little bit about arc length first. All right, so arc length is basically a piece of a circumference. So it's the portion of a circumference. So if you think about, a circle, and then if you want to have, if this was a pizza, right? Here's my little pepperoni pizza. All right, it's not a cute pizza, but there's my pizza. All right, well, the arc length is the crust of the pizza. All right, the outer edge. So it's a portion of the circumference. But pretend that you have this pizza, and if you measured it all the way around, the circumference might be, I don't know, 30 centimeters or something like that. Well, what if I took only one slice of pizza? Then what would this length be? Okay, so the length of the crust, basically, and you can measure that with a like a measuring tape or something like that. So it's one-dimensional because it's just length. So how long would that crust be if you actually measured it? All right, so that's what we're going to be looking at for arc length. All right, so let me go back, sorry. All right, so arc length has a formula, and the formula is 2 pi r theta over 360. You'll notice that 2 pi r is really just the circumference formula, right? So the circumference formula, it's because it's a piece of the circumference, it's a portion. All right, the theta over 360 is how much of the pizza or how much of the circle does it make up. So theta is the angle in which it makes up out of 360. So really it's a ratio. So think about if you had, a circle, if I divided that into 4 equal parts, well, then a circle is 360 degrees, right? So each circle, or each piece rather, would be 90 degrees because 90 plus 90 plus 90 plus 90 is 360. All right, so we're looking at a ratio. So 90 out of 360 would really be like a fourth of the circle, right? So this theta over 360 piece is how many degrees out of the 360. Now, we don't have to reduce that ratio, but basically that's what it is. 90 out of 360 would be 1/4, okay? So that's what that is talking about. All right, so if we look at the first example and we use that formula, then here's my formula. I'm using the arc length formula because it's a piece of the circumference, and I'm substituting in. So I know that that 2 pi is part of my formula. The radius is 3. The theta of the shaded region is 45, and it's always over 360. And so then I put that in my calculator using n over d, and then I can look at that as a, in pi, like as a fraction, or as a decimal. So if you use the n over d button on your calculator, it's going to give you 3 pi over 4, and then you can hit the convert button and get the 2.356. All right, so that's how you get that. So ultimately, think about length. If the radius is 3, this is, 2.356, so almost 2.5 inches long, right? So just think about, in reference of length in general, does it make sense that that little curved part would measure to be just a little bit less than 3 inches? Yeah, sure. So obviously make sure that things are actually legit, making sense, okay? So if we look at the second example, same formula because we're talking about arc length, all right? But this time, my radius is 6, and my shaded region makes up 115 degrees out of the 360. All right, so if I use n over d and put that in my calculator, I get 23 pi over 6. If I convert it to a decimal, I get 12.043 centimeters. Again, this length right here, the radius is 6. This curved part, the crust part of my pizza, it definitely looks like it would be longer than 6, right? So it would measure, about double of that length if you actually did measure it. All right, so that is what arc length is. So take a look at example 3. Example 3 is a little different because the arc length formula uses radius, but they don't give us the radius, they give us the diameter. So you got to remember that the radius is half of the diameter. So we're going to substitute in 21 and not 42. So my radius is 21, 50 degrees is shaded out of 360. Put that in your calculator and then convert that to a decimal. All right. For this last example, you'll notice that the shaded part, they don't give me a measure, right? I know the unshaded is 70, but what are they asking for? Well, they're asking for the shaded region, right? So they ask for the shaded region. I know that the unshaded region is 70 degrees. So if I subtract from 360, 360 degrees minus 70, I get 290 degrees. So this little part right here would be 290 degrees. All right. So I don't care about the 70. I care about the shaded region, remember. All right. So when I set up my formula is the same, but this time my radius is 9.7, but I'm looking at 290 degrees out of the full 360. And then I get 49.096 feet. And it would make sense that if this length right here is 9.7 feet, this curved part of the shaded region is significantly longer than that, right? So close to 50 seems like it should be pretty accurate. All right, so now I want you to hit pause and try 5 through 8 at the bottom of your paper. So you should be at the bottom of page 6 and trying numbers 5 through 8. All right, so if you want to check your answers, these are the answers that you should have gotten. I didn't put the units of measure there, but you should at least have enough information there to check your work. All right, so remember arc length is the crust of the pizza. All right, crust of the pizza. It's a portion of the circumference. So it's like if you took a slice of pizza and wanted to know how long the crust part of it was. All right. All right, so the next thing we're going to look at is sector area. Now, sector area is when you have a piece of pizza. Whoops, that's showing you some stuff. Let's see. If you have a piece of pizza or a pizza, and I'm not going to do all the pepperonis and stuff, but if I have a slice of pizza, I want to know how much area is that slice of pizza. So, like, how much cheese is on the pizza. Okay, so I'm not looking at the outside crust anymore. I'm looking at all the toppings. All right, so that's what a sector is. So it's not a triangle because remember, triangles are 3 straight sides. This has 2 straight sides and 1 curved side. All right, so that's what a sector is. An area is surface area. So we're trying to see how much area does that take up. All right, and you can see the formula up here in the top corner. All right, pi r squared theta over 360. Pi r squared is the formula for the area of a circle. The theta over 360 is just the ratio. So you're using area of a circle technically, but then you're saying, well, but I don't want the whole circle. I need just a portion of that 360 degrees. Now on this paper, it's asking you for the shaded and the unshaded region. Okay, so you'll have to write kind of small in order to get it all to fit. But the reason why I did that is because a lot of times we get so focused on the shaded region, and sometimes they don't want that part. Sometimes they want the unshaded region. So I want to make sure that you understand how to get both parts. All right. So first things first, if we look at example 1, if the shaded region is 80 degrees, then what in the world, how would I get the unshaded region? Well, if the whole circle is 360 degrees, then what is 360 minus 80? Well, we would get 280. So that portion of my circle is 280 degrees. All right. So I'm just going to kind of slide this up so you can see at least how to get that. All right. Now, if we look at the second example, in the unshaded, we would have to subtract the 135 from 360, and we would get 225 degrees. Okay, so that's where that is coming from. All right, so if we look at this first example, we're using the formula above, pi r squared theta over 360, but because of space, I didn't rewrite the formula. All right, so I substituted in the 4 for my radius, 80 degrees because that's the shaded region over 360. And then in my calculator, I would get 32 pi over 9, but if I convert it to a decimal, I get 11.17 square feet. Now remember, we're not looking at length here, we're looking at coverage. So how much space does it take? Like how much space is there to throw all my toppings? All right. Now the unshaded portion, we're going to use, instead of 80, we're going to use the 280. So the formula is the same, we're just using the other degree. All right. And then you get 112 pi over 9, or 39.095 square feet. Now think about these measurements. The shaded part is like 11 point something, and the unshaded part is 39 point something, right? It's almost 4 times as big. So think about size here. Does that make sense, right? So, and yes, it does. It does make sense because there's a lot more unshaded than there is shaded. So the fact that the unshaded square footage is significantly larger should make sense. All right, so then for example 2, we're using the formula above, but my radius is 6. My shaded region represents 135 degrees. So when I put that in my calculator, I get 27 pi over 2, or 42.412 square centimeters. Again, it's square units because we're talking about area, and area is two-dimensional. All right. The unshaded, we're going to use the 225 degrees. So I should get a bigger number than 42, right? Because 135 is smaller than 225. So I'm going to substitute that into my calculator, or my formula rather, and then here's my final answer. All right, so 45 pi over 2, and then 70.6862 centimeters squared, or squared centimeters, which is larger than the shaded region. So that should make sense. All right. Now, if you look at example 3, you'll notice that again we have the diameter. All right, so you've got to be careful. So you need to know a few things about a circle. Number 1, a circle is 360 degrees, right? But if I want to know half of a circle, then that's 180 degrees, and that's going to help us later. But here we can just say 360 minus the 55, and we get 305 degrees. All right, so the unshaded part is 305 degrees. On example 4, 360 minus the 72 degrees gives us 288 degrees. All right, so that's how many degrees is in the shaded. So this time they gave us the unshaded, but we needed to figure out the shaded. So it just depends on what information they give you. So back to example 3. Again, they give us the diameter, so we do need the radius. So I substituted in 21 instead of 42. The shaded region represents 55 degrees. So when I put that in my calculator, I get 539 pi over 8, or 211 point blah, blah, blah squared millimeters. For the unshaded, I'm putting in the 305 degrees. So that's where that comes from. And you can obviously check your work. Okay. All right. Any questions or concerns, just make sure you send me an email, get on our Google Meets, and we can definitely talk about these. All right. So example 4, we're still using this formula up top because we're talking about the area of a sector. So remember, that's a portion of a circle. Okay. Like a slice of pizza. So if I substitute my numbers in, the shaded region, well, first of all, the radius is 8.4, but the shaded region is 288 degrees. So a common mistake is people see 72 and they automatically want to use it, but that's not the shaded region. So make sure that you're using the right numbers. And this time I don't get an answer with pi because of the decimal, but I get 177.337 square feet. So for the unshaded, I should expect that to be significantly smaller, right? Because this is a whole lot of shaded space and not a lot of unshaded space. So when I put that in my calculator, I'm using the 72 degrees this time, and I do get 44.334 square feet. All right, so at this point, you can press pause and try numbers 5 through 8 at the bottom of your paper and see how you do. All right, so if you have completed those, you can see, hopefully if I can get it uncovered, you can see the answers below on the screen, so you can check your work as you go. Just please make sure that you're actually checking these. Substitute it into your problem. You will submit your work, so I don't want your answers. I mean, obviously I need to see the answers, but what I really want to see is how you're substituting in. So make sure that in order to get credit, I do need to see how you're substituting into the problems, just like I did in my examples, and then show me your answers. Okay. Again, today we talked about arc length and sector area. So remember, arc length is the outer edge of a pizza. All right. And let me stop sharing my screen. All right, so arc length is the outer edge of a circle, and that is a portion of the circumference for the arc length. I mean, it could be the whole circumference, I guess, but typically it's just a portion of it. All right, and so that's why that formula has the 2 pi r in it, because it's a portion of the circumference. Remember, that's like the crust of your pizza. So they sometimes will talk about like tires and things like that. So if you want to know, like if you had a bicycle tire and you wanted to know the distance between one spoke and another spoke, well, what is that distance between the two? That's arc length. All right. And then we have sector area, which is like a slice of pizza, but you're finding the whole entire area of the pizza. Okay. And then looking at that one slice. So it's surface area. And so you're using pi r squared theta over 360 since it's a portion of the area of the whole circle. All right, so y'all have a good day, and I will see you soon. Bye, y'all.